Good morning, ladies and gentlemen. I hope you're all doing well. Since this semester commenced, we've had a series of lectures on geophysics, right? We started by looking at what geophysical exploration techniques. Through that, I remember I passed you through each technique, especially the 4 techniques we are going to look at, or we looked at, and the applications. We did the gravity methods, you recollect, and then we did the applications. And we also did the geomagnetic methods and applications. And we even looked at what geomagnetic or magnetic surveying. Then we proceeded to look at what we call the seismic methods, which comprises the seismic reflection and refraction methods. And for the applications, I've asked that we have a presentation on applications. So today, that's what we are going to do. Okay, and I hope you're all well prepared. Thank you. Thank you. So we'll begin.
Under the rock quality assessment, we are coming to do the case study. The first case study we found was this one: construction of a highway tunnel located in Switzerland, the Swiss Alps. So this is the tunnel. So the objective was to assess rock quality. Tunnels, cars are going to pass there, human life will be at risk. So they have to take note of like whether there are faults, fractures, any weaknesses.
Applications of VSP in oil and gas industry. So with the application, we are going to mention the case studies and then where it was used and then the advantages. So the first few applications will be reservoir characterization and wall correlation. So with these 2 points, it was used in the Gofax field in North Sea by Equinor, and then they used seismic data together with surface seismic data to get a more accurate geological model. And then we also went to seismic calibration. And then with this application, it was also used in Prudhoe Bay in Alaska. And then they used it for planning hydraulic fracturing. So they used the data they got to be able to get the exact dimensions for which will give an optimal hydraulic fracturing.
So once you carry out the seismic survey, you are going to, so from what my colleague said, you are sending down waves to hit the sea floor, then you get a response. So which are the reflections. So those, some of them will be absorbed by the seabed. Most of the reflections that will come to surface will help you to categorize or will be able to help you picture what is actually going on beneath the sea. So what we have here is the wave trains. So each event of you sending an incident ray down the seabed will send you back a reflection, and these are called trains. And these trains will help you to structure the seabed.
First of all, land use refraction seismology to determine the depth of the landfills. So what we do basically is that we know that seismic waves travel through materials with different properties differently, and so we send the waves through the waves, and we determine with their different travel times, we determine the depth. So we know that the depth, the waves goes in and is refracted back. So we calculate the depth of the waves rate. D is equal to VT over 2, right? Because we know that seismic waves travel through different materials with different speeds. Also, we measure the P wave velocities of the fill and substrates. So what we do is that P wave velocity is an indicative property of every material. So every material has its own P wave velocity. So because wastes are more heterogeneous and unconsolidated, the P wave velocities in them are low, and for hard and consolidated materials such as subsurface, the P wave velocities in them are high. So we can see them here. So we can use that to determine whether differentiate between the waste and the land.
So for our presentation, we are determining the rock head for a proposed waste disposal site. So the rock head is just the top part of the bedrock. We are going to use seismic reflection and refraction methods to determine the depth of the bedrock